Okay, hello everybody. We've got another video today, integrating exponential functions. All right, but we're going to start with today. We're going to do a knock knock joke. So let's try it. Knock knock. You're supposed to say who's there. Oh, do I leave it there? No, it's okay. Okay, knock knock. Tank. You're welcome. I don't know if this is going to translate on video, but that's fine. All right. So again, we said integrating exponential functions. Now, the good news is if you know how to differentiate exponential functions, which hopefully you should by now, you'll know how to integrate. So a couple of things here. If y equals e to the x, y dash equals e to the x. We remember that. That's nice. So it makes sense that if we integrate e to the x, guess what? We should get e to the x. And don't forget your plus c. Okay, remember, only plus c if it's indefinite. So there's nothing going on here. If there's no bounds, we need the plus c. If there's bounds, don't worry about it. Okay, now that's if you've got a simple kind of exponential. Now, if we've got an exponential that's raised to no longer just an x, but maybe a 2x or a 2x squared or something fancy, we know that if it's e to the fx, your derivative is, your derivative comes down the front, then you multiply it by the original function. But if you have e to the fx dx and you integrate that, what you should get is you should get 1 on f dash x. So instead of multiplying by the derivative, this time we're going to divide by the derivative, and then the rest will stay the same, plus c. So makes a lot of sense. Let's do some numbered examples so it starts to look a little bit more real. Okay, I'm going to move on. Hopefully you got that down. Boom. Let's get some questions here. The first one, maybe I'll keep that there. Find the integration of 2e to the x. It's just going to be, or e to the x integrates to e to the x. The 2 is just a scalar, it's just a multiplication. So it's actually just going to be 2 to the x, 2e to the x plus c. Nothing changes there, okay? That's it. Okay, now if we have something like this, 4e to the 4x dx. Now remember, when we integrate this one, we're going to take 1 on 4 out the front. We're going to times it by our original, right? Because we're doing 1 over. So the derivative of 4x becomes 4. So we're going to divide that out the front. So instead of dividing by 4, I'm timesing by a quarter. Okay. And then I don't need the plus c because I'm going to integrate it between 1 and 0. And I'm just going to clean that up before I keep going a bit further. That's just going to become e to the 4x because the 4 and the 4 will cancel out. So it's e to the 4x between 1 and 0. And that's just going to be e to the 4, take away e to the 0. And I'm going to leave e to the 4 as is. But e to the 0, anything to the power of 0 is just 1. So that there is evaluated. Boom, e to the 4 minus 1. That would be your answer. Cool. So that's a little bit how this formula works. Just remember, it's very easy to get confused with derivatives and integration. So just remember, with integrate, you need to divide. Okay, for differentiation, you need to multiply it out the front. For integration, you need to divide the derivative. Okay. Now, another very common type of question is they're going to give you a derivative, and they're going to want you to find not the f dash x, sorry, but the original function. So if you've been given the first derivative and you want to find the original function, you're going to have to integrate. And they also give you something here, and I'm going to highlight this. This is what they'll often call, these are going to be the conditions, and it's basically to help you find C. Right, because every time you integrate, you get some sort of constant. And so they give you just enough information to solve what C is. So let's do this here. We've got this. We've got integration of 3e negative 3x plus x dx. And let's find out what this is. So I'm going to take out the front is, we've got that negative 3x. So if I derive that, I'm going to get 1 on negative 3 or negative 1 on 3, whichever way you want to put it. I'm going to multiply it by my original 3e to the negative 3x. And then my plus x becomes plus x squared on 2, just using our usual standard derivatives. And I'm going to put this in square brackets for now. Or actually not yet. I'm just going to add plus c. Okay. Now, cleaning things up a little bit. This is now my fx. It's no longer my f dash x. It's going to become the negative 1 on negative 3 times positive 3 cancels out, leaving me with just negative e minus 3x plus x squared on 2 plus c. And so now I'm going to use my f of 0 equals to 3. So what that means is f of 0, I'm going to put this to the side here. And all this is saying here is it says, that thing is trying to say is when my x value equals to 0, my fx value should equal to 3. That's what that means. Okay, so if that's what that means, let's substitute when I'm going to put 3 on this side. And for every x on the right-hand side, I'm going to let that equal to 0. So negative e, negative 3 times 0, plus 0 squared on 2, plus c. And all of that, when I add it up together, should equal to 3. So what is negative e to the negative 3 times 0? Just negative e to the 0, which is just negative 1. Okay, let's remember anything to the power of 0 is 1, but we've got that negative, so it becomes negative 1. 0 squared on 2 is just plus 0, plus c, that's what we're trying to solve for, and that all equals to 3. Okay, taking it a bit further here, I'm just going to plus 1 to the other side, c would equal to 4. And so now my fx, I can rewrite, and instead of writing plus c, I can rewrite it as negative e to the negative 3x plus x squared on 2. And then instead of saying plus c, I'll just go plus 4. And that there becomes your fx. All right, we're doing good. Hopefully we're keeping up. Last one here is sometimes they'll ask you to do some sort of, what do you call it? Some sort of chain rule kind of thing. So if we've got e to the x squared, they'll say differentiate e to the x squared and hence find between 0 and 2, 2x e to the x squared dx. All right, not as difficult as it's going to look, so let's try it out. So if I have e to the x squared, if y equals e to the x squared, my y dash becomes the derivative of my power, which is going to be the derivative of x squared is going to be 2x, and it's going to be just times e to the x squared. So if you take a look here, that's my derivative, isn't it? That's exactly the same thing. So in other words, if I was to integrate between 2 and 0, 2x e to the x squared dx, I know the integration is going to go back to my original. It's just going to go e to the x squared, right? I'm going to e to the x squared, and I'm going to evaluate this between 0 and 2. So this is going to be e to the 2 squared, which is 4. Take away e to the 0, which again is just e to the 4, take away 1. And that there would be how you do that. Hopefully that makes sense. And hopefully you enjoyed doing this one today. I've given you quite a lot of questions, but all the questions shouldn't take each question shouldn't take too long. So enjoy, be good in class, and I'll catch you guys later. All right, bye-bye.